This Working Scientist podcast series is sponsored by the University of Queensland, where research is addressing some of the world's most challenging and complex problems. Take your research further at UQ. Visit uq.edu.au.
Hello, this is How to Save Humanity in 17 Goals, a podcast brought to you by Nature Careers in partnership with Nature Food. I am Juliana Gil, Chief Editor at Nature Food. Welcome again to the series where we meet the scientists working towards the Sustainable Development Goals agreed by the United Nations and world leaders in 2015. Since then, in a huge global effort, thousands of researchers have been tackling the biggest problems that the planet faces today. In episode 4, we look at Sustainable Development Goal number 4, how to ensure quality education for all, and meet an engineer from Uganda who is changing the way children learn science right across the African continent.
My name is Solomon King Benge, and I'm the founder and executive director of Fundi Bots. So FundiBots is an organization based in Uganda that is working to improve and accelerate science learning in Africa. We focus very, very heavily on science subjects. And the goal for our work basically is to move the quality of education from theory-driven, blackboard-centered learning to highly practical, student-centered learning in which the pedagogy revolves around understanding the practice as opposed to academic excellence, which typically leads to rote memorization and all that. So we use multiple tools. The one that we are most known for is the Robotics tool, where we teach children in primary school and secondary school and some university students how to work with robots. And the goal is that the journey of building a robot is a journey of discovery that is exciting. Once a child sees a demo robot, they're so excited to get it working. So they sort of like give us permission to teach them. So I like to call it permission-driven education. The other tool that we have is a little more aligned to the curriculum. So it has a more academic bent in that it is designed to integrate directly in the national curriculum. And the reason for this is when we were analyzing the results of our work, the big question that came to us was, how do we create more impactful learning where the problem center is? And the problem center is typically within the classroom, and that is what resources do teachers have to teach science well, and what resources do students have to understand the content. So we built something that we call the enhanced science curriculum, and the goal for that is to integrate directly into the national curriculum, almost word for word, but provide high quality tools that both students and teachers use in the classroom to transform the classroom from a blackboard-centered activity to students working in groups, sharing their findings, and making exciting discoveries about science. So Sustainable Development Goal number 4 is ensuring quality education. And the goal is to ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. So the advantage that we have is a lot of the Sustainable Development Goals are general quality of life ambitions that any country or the world should have. The categorization is helpful, but it is something that we are inherently working on. So the goal has quite a few targets, and almost all are very aligned to the work that we do. So ensuring that girls and boys have equal and free education, ensuring access to quality technical and vocational education, early childhood development, etc., technical skills, vocational skills, all of those are very, very highly aligned to what we are doing. So we are working towards it, but mostly because of the necessity that we have. Our long-term goal is to work with more than 1 million students across Africa. Currently, we are primarily based in Uganda. We have done trainings in Tanzania, we have done trainings in Kenya, and we've done some trainings in Rwanda as well. But our goal is essentially to replicate all this effort across the African continent. So the story of FundiBots, the journey of FundiBots is, I like to tell people that I am essentially reaching back in time to try and redeem myself. I was the kind of kid that you find in a neighborhood tinkering with like electronics parts, like trying to understand what made these things tick. Like a radio is dead, but why is it dead? I grew up in the 90s and it was rife with a lot more accessible electronics. So a lot of electronics these days, it's like very embedded. It's very hard to get parts from it. But back in the day, you'd open up a radio and you find electric motors, you find wires, you find all these things that for a curious child was just like heaven. And so I was that child. I was essentially trying to understand how things work, putting things together, making toys that were very unlike the kind of toys that my fellow kids were making, because mine were driven by electricity. And the frustration that I felt was even more in the academic setting, because in school, it was just about memorizing information so that you could pass an exam. And I found that pretty frustrating, because even at that age, I still felt like there had to be something a little bit more to education than just sitting in a classroom and memorizing facts. When I got to secondary school, I discovered that it was just another higher profile academic setting where everything that you did, even when it was practical, was aligned towards getting the facts you need so that you can pass an exam. The moment of inflection for me that both solidified my desire for an alternate form of learning, but also increased my frustration, was discovering a very amazing book called The Engineer in Wonderland by Eric Laithwaite. And he used to give Christmas lectures at the Royal Academy of Sciences or the Royal Society. And he wrote a book called The Engineer in Wonderland, and I love to read. So the story of Alice in Wonderland immediately resonated for me. And it was this very complex book on electricity and magnetism, but he told it in such an approachable way that even a child like me could understand. And it was just so much fun and so exciting. And so I got the book, went to my physics teacher and said, hey, can we do this? This looks like something that kids would actually enjoy learning. He took one look at it and essentially said, don't waste your time on this. This is not important because it's not in the curriculum. So at that point, subconsciously and resolutely, as you know, as far as a 14, 13-year-old can be resolute, I realized that, this education as it was just wasn't the thing for me. But in 2011 is when the FundiBots story sort of came back full circle. Because when I got that rejection from the teacher, the first thought that came to mind was, there has to be something better than this. And that something for me was a place of learning where kids would not be judged on what was exciting for them. They would not be pressured into, academic environments, but it was a place where knowledge was free, that kids were mentored, etc. So that sort of stayed with me, lingered at the back of my mind. I basically told myself that this dream that I had as a child, I think I can start working on it now. I started FundiBots as a hobby, and then in 2014, it became a full-time organization. So what started as a solo, project began attracting people. We began working with more and more students. We began attracting a lot of funding. And right now, we are at a stage where we are a team of 125. And last year alone, we trained more than 22,000 students. Our interventions are in three major areas. One is learning from home, which we call the Fundi at Home program. The other is learning to prepare for work, which is a more skills development-oriented perspective, which we call Fundi at Work. And then the big one is school-based, which we call Fundi at School. So each of those provides learning options and learning perspective for students in different ways. And so the 1 million that we want to reach, the majority of them are in schools. The ones that we reach directly are in schools. But we are also building digital content that children can access through the internet. So YouTube is a current primary platform. But this year, we plan to roll out an online learning system where any kid across Africa can log on, with the help of their parents, of course. Any kid across Africa can log on and begin learning the material that we are teaching. We also want to do broadcast, which essentially means putting our content on TV and syndicating it across the African continent. So when you look at those very highly scalable options, they may not be as practical as we would like, but it still allows us to reach a significantly diverse and significantly broad audience. And the hope is that in every single one of those interventions, we will create ways in which kids can learn experientially by trying out experiments on their own, but also academically by having a high quality learning perspective in the classroom. So our learning models are essentially centered around what kind of access we have to the children. The robotics program tends to happen more on the weekends. Some schools might give us some classroom time, but typically they happen on weekends. It's like an after-school program bordering on a club basis. So we do have teachers that go to these schools every single day and work with the students and other teachers. So we have a lot of teachers on staff. The vast majority of our staff members are teachers that support other teachers in schools. So they will go to schools. They might have a suitcase full of electronics, or they might be on a DIY project, and so students are asked to pick up cardboard, some wires, some materials from their neighborhood, and the goal essentially is to lead them on a journey where they make these things themselves. The big challenge with robotics education initiatives is that many of them are from the West and they're very top-down. They don't take into consideration the local perspectives and the local contexts. So you'll find a child is being taught robotics using a $300, $400 robot, and their first instinct is, this is exciting, but I cannot do this because I don't have this kind of money to go and buy something. The FundiBots model is completely different. We teach kids how to make all sorts of gadgets out of cardboard, wood, plastic, wires. When you look at the robots that our kids make, you can tell that that was built by a child and that they know exactly how it works, you know. And so for us, that is exciting because we open up a lot more creativity, innovation, and ingenuity. The vast majority of robots that our students build are what we call rovers, which is essentially a four-wheeled vehicle. So that's a machine that has tires, a couple of wheels, is controlled by some sort of very rudimentary circuit. So depending on the age of the child, that rover can get more and more complex, or it can get very, very simple. Sometimes all you need to do to get a kid excited is for them to actually connect a motor and a battery and see their thing move. And so it stretches the gamut all the way from something as simple as that to something like a robot that is trying to navigate its way around an environment. On the other hand, we also have students that build projects like greenhouses that are controlled by smart home software. We have students build mock traffic lights for the roads in their villages. One of my most exciting one was when we taught this kid in northern Uganda how to build a sensor-driven robot, and we asked him, so what do you think you can do with this? And his first reaction was, I think I can now create something that lets the goats out of the pen in the morning so that I don't have to wake up early, right? And while it was hilarious for us, it was just a very real testament of once you empower children and make learning meaningful, then they actually begin looking at the practical applications of that learning. It's no longer about an exam, it's about actual real-world solutions. In fact, one of the things that we actively encourage is our students to be able to consider a problem in their communities that they can provide a solution for. One of the ones that gives us tremendous joy is a group of students from northern Uganda that made a solar-powered cooker that ended up in the news headlines, and they actually won a sustainability award at the recent climate change conference in Dubai. So none of this would have been possible if we had a rigid structure that was very guided. We like kids to explore, we like them to experiment. And so our robotics program is not 100% robotics in the traditional sense, but the robotics is a gateway for kids to begin exploring the capabilities of electronics, of mechanics, of computing. So they can go on to explore programming or to explore electrical engineering or mechanical engineering. They don't have to do robotics. In order for sustainability goal number 4 to be achieved, I think the biggest player in all of this is government. We need to have very, very strong intentionality from the highest levels. You can have as many actors like FundiBots, as many individuals, as many organizations trying to change this landscape. But what we are essentially doing is the government's work. We do not have the capacity, interest, or finances to employ hundreds of thousands of teachers. This is supposed to be government work. We do not have the resources and the infrastructure to provide learning materials for an entire continent. But the reason we do this is because at the highest levels, there is no capacity, no intentionality, or no interest in funding some of these things. And even if there is interest, even if there is intentionality, there's always a breakdown because there's so many factors from a policy perspective. From the moment a decision is made to the moment of implementation could be years. And in that time, millions of kids have passed through the school system and their lives have been changed. Literally every single day that passes, there's a kid that's dropping out of school who could have benefited from a high quality education. So these decisions that take time, I understand that the time is necessary, but they're extremely costly from a human capital perspective because these are the kids that we need for tomorrow's workforce. So the biggest intentionality has to start from the top. I would say that it pretty much narrows down to the most critical actors are teachers. We need to put teachers as high priority workforce, looking at quality of training, quality of compensation, quality of tools and resources that they're given. We need to empower teachers to love the work that they're doing, and we need to, quite honestly, pick the best teachers because many teachers get into the profession because it's a last resort. So I think that for me, teachers are the biggest catalyst. And if we train them right, if we filter them right, and if we give them the right resources, then that goal is basically achievable on its own. But there has to be maximum intentionality at the government level. I absolutely love my job. The part that I love the most about my work, I no longer do, and that was the tinkering, the training, and interacting with the kids. Like I really, really love teaching. Unfortunately, my work now is more about fundraising, so I spend more time in Excel and Word compared to like a lab and programming or soldering stuff. But I do love the impact that we're having on the lives of children. I love it when teachers tell us the impact that our work is having on not just the students, but on them as well. So it's really exciting. It's very exhausting. It's very draining sometimes because my work is to fundraise. So looking for the money can be an exhausting and disappointing process. But it's always about we just need to keep grinding because the kids need this. Like I said, every day that passes, there's a child that's going out of the system, and we have failed that child.
Thanks for listening to this series, How to Save Humanity in 17 Goals. Join us again next week when we look at Sustainable Development Goal number 5, how to achieve gender equality and empower all women and girls. See you then.
This Working Scientist podcast series is sponsored by the University of Queensland, where research is addressing some of the world's most challenging and complex problems. Take your research further at UQ. Visit uq.edu.au.